Hi, Stephanie from DesignCode. I don't know if you're on TikTok or you know this TikTok trend, but let me show it to you. So I watched a few TikToks related to this trend and it got me thinking, how do you code a Face ID authentication in SwiftUI? This will be the subject of today's video. So this is authenticating with biometrics. And this is a must-have nowadays, even more so if you're building an application with sensitive information like a financial application. You can also implement login with biometrics to speed up the login process for your users, and they won't need to always remember their credentials every time they try to access your application. So let's explore how to implement that in a SwiftUI application. But first, what are biometrics? Biometry is a term made out of two Greek words. The first one is bio, which means life, and the second one is metry, which means measure. In other words, when working with biometry, we're measuring and calculating some human characteristics like the eye, the face, or the fingerprint to authenticate a user. Biometrics authentication is some fancy words that means, in Apple's environments, authenticating the user with either Face ID or Touch ID, depending on their device and the biometrics authentication available on that device. If both Face ID and Touch ID aren't available on the device, for example, in the case of an iPod Touch 7th generation, we'll fall back to a login with credentials, so with a username and a password. For this tutorial, make sure you have Xcode 13 installed on your computer because we'll use some new features introduced in iOS 15 and it's only available in Xcode 13 and higher. We'll also be using the local authentication framework from Apple to implement the biometrics authentication process. Moreover, we'll code a few views to simulate a logged in and logged out user. So let's start. First, let's create our Xcode project. In the model that appears when you launch Xcode, click on Create a new Xcode project. In here, make sure that you're under the iOS tab and select App. Then click on Next. We'll need to choose the options for our project. So give your project a name. In my case, I will name it Authenticator Demo and select your theme, and your organization identifier is the reverse of your URL. In our case, since our website is DesignCode.io, we'll need to reverse it and we'll write io.DesignCode. Make sure the interface is SwiftUI and the language is Swift. Usually, these are the default values, so you don't need to change anything. Then, click on Next. Choose where you want to save your project and then click on Create. When creating a new project, I like to change the target device, so instead of iPod Touch, I will select an iPhone 13. We can also go to our Assets folder, and under App Icon, we can add the icon for our application. So I have my folder containing all the icons, and I'll simply need to drag and drop each icon for the specified size. For example, I have a 20 by 20 pixels icon, so I will drag and drop it into the 20 by 20 slot, and I will do the same for all the other ones. Now that I'm done adding all the icons, I can move on and start coding. The first thing we will start coding is the login view, which is this view that you can see here. This view will contain a title as well as a button that will be adapted to the biometryType available depending on the user's device model. So that would be either login with Face ID, login with Touch ID, or login with credentials. So let's go back to our Xcode project and we'll start off by creating the title because we'll reuse this component in multiple views. We'll create a component out of it. Under the Authenticator demo folder, let's create a new group. And we'll call this group Components. I will move it right after the content view, and I will right click and create a new file. It will be a SwiftUI view, and we'll call it Title. Then click on Create. And this title will simply be a text with some modifiers added to it. So instead of Hello World, we will write Authenticator, and we'll add some boldness to it with a font of title and a foreground color of white. So since the background is white and the text is also white, we can't see the text. To fix that, we can go to the title preview and we can add a background color. Let's add a linear gradient color, which will be the same that you can see in this view. So we'll call the linear gradient, and you can see that it takes 3 arguments: colors, a start point, and an endpoint. So the colors is an array of color. Let's add blue and purple. The start point will be top leading, and the endpoint will be bottom trailing. Now you can see that we see a background color on the title, and we can now see the authenticator title. Since this is only the preview, we don't need to spread the background color on the entire screen. The next element to code is the button. So still under the components folder, let's right click and create a new file. This file will be a SwiftUI view, and we'll name this primary button. Then let's create it. This component will accept 3 arguments. The first one is an image, and it will be optional because we might not show the image on the button. And since we might not show this image, let's create a variable called showImage and set it to true. If we don't want to show the image, we'll pass the showImage argument when calling this primary button and set it to false instead. The last argument is a text, and it will be a string, and this one will be required. And you can see that now the preview is missing the argument text. So let's add an image and a text. The image will be the Face ID image from SF symbols, and the text will be login with Face ID. Let's remove the text hello world and add an H stack instead. Inside of the H stack, let's add an if statement. So if showImage is true, we'll call the image view and pass a system name. The system name will be the image variable that we pass to this component. And you can see that we have an error because the image is optional. So let's add a fallback, and we'll add a person fill. Right below this if statement, let's show a text, and it will be the text that we passed to this component. So right now you can see our little Face ID icon with the text login with Face ID. Now on the H stack, let's add a few modifiers. We'll add some padding all around it, and we'll also add more padding horizontally. Then the background will be white and with some corner radius of 30 pixels. We'll also add some shadow with a radius of 10 pixels. So you can see that our button is now completed with some padding, corner radius, and some shadow around it. Now that we're done with the 2 components in our login view, we can now create our view. So since we'll have a few views, let's create a group called views. And we'll drag and drop the content view inside of the views folder. Now let's right click the views folder, create a new file, and this file will be a SwiftUI view, and it will be called LoginView. Let's remove the text hello world, and we'll add a vstack with some spacing of 40 pixels. Inside of this vstack, we will add the title, as well as a primary button. Remember that it requires some arguments, so we'll pass an image, which will be Face ID, and the text, which will be login with Face ID. So right now we cannot see the title because if you remember, we added a white foreground color. So on the vstack, let's add a frame with a max width of infinity and a max height of infinity as well. Then let's add a background color, which will be a linear gradient, and we need an array of colors, so it will be from blue to purple. The start point will be top leading, and the end point will be bottom trailing. So now we finished our login view, and we hard-coded a primary button for Face ID. However, after implementing our Authentication Manager later on and getting the biometryType available for the current device, we'll add a switch statement instead. Now let's call our login view in our content view. So let's go to content view, and let's remove the text hello world and add a vstack. Inside of the vstack, we'll call our login view. On the vstack, let's add a frame with a max width of infinity and a max height of infinity as well. Next, we'll call the edges ignoring safe area.all so that it covers the entire screen, and the background color will also go over this safe area at the top and at the bottom of our screen. Now let's create our Authentication Manager. So let's right-click on the authentication demo folder and create a new file. This file will be a Swift file and we will call it Authentication Manager. Then let's create it. Inside of this file, we'll need to create a new class called Authentication Manager that will conform to the Observable Object Protocol. At the top, after importing Foundation, we will also need to import local authentication. This is the framework we'll need to implement biometrics authentication. The first thing we need to do is to get the biometryType, but first we need to create a context. So let's write private set, meaning that this variable can only be set within this class, and this variable will be called context. It will be equals to LA context with parentheses at the end. We need this context to use FaceID or TouchID and authenticate the user with biometrics. If we take a look at Apple's documentation, when we call the LA context mechanism, we need to update our Info.plist file. Otherwise, we'll run into a crash. The Info.plist file, or property list, is the file that contains all the configuration details related to your application. Inside of this file, we'll also include all the keys related to important behavior of your application, for example, the usage of biometrics authentication. If you're using Xcode 12 or older, you'll find the info.plist file on the project navigator on the left side, where the folders and the files are located. If you're using Xcode 13, the info.plist file is a bit more hidden. We'll need to click on our project name, and under targets, we'll need to click on the info tab. You'll see your info.plist file under the custom iOS target properties. Hover over any key and click on the plus sign next to the key. We'll need to copy the NS FaceID usage description key and then paste it in the place of the key. If you hit enter, it will automatically be renamed to privacy FaceID usage description. Leave the type as string, and for the value, you need to provide a short description as to why you need to use FaceID. For example, I will write allow FaceID to log into the app, and then hit enter and it will save your info.plist file. Now let's go back to our Authentication Manager and get the biometryType. If we take a look at Apple's documentation, you can see that the biometryType is the type of biometric authentication supported by the device. And we can go into the LA biometryType page of Apple's documentation, and you can see the types of biometry available with LA context. It can either be none, which means that no biometryType is supported, FaceID, which means that FaceID is supported, or TouchID, which means that TouchID is supported. So right below the context variable in Xcode, let's create a published private set variable called biometryType, and it will be of LA biometryType, and by default, let's set it to none. We'll also need to create another variable, which will be private set var can evaluate policy, and it will be equals to false. We will reassign this value in the function we'll create now. So let's create a function called getBiometryType, and the first thing we need to do is to call our context dot can evaluate policy. We can go to Apple's documentation and you can see that the can evaluate policy function accepts two variables. The first one is a policy, which is of LA policy type. The LA policy can be all of the cases enumerated on this page. In our case, we'll use the first one, which is device owner authentication with biometrics, which means that we'll authenticate the user with biometry. The second argument in the can evaluate policy function is the error, but we don't need it, so we'll simply pass a nil value to the function. So for the policy, we will write dot, and we will select the device owner authentication with biometrics. The error, as I mentioned earlier, will set it to nil. And this function returns a Boolean value, which will let us know if the biometrics are available with the current device the user is using. So let's save the result of the can evaluate policy in the can evaluate policy variable that we just created on line 14. And next, we'll need to set the biometryType. So biometryType will be equals to context.biometryType. And we want to call this function onInitialize of this class because we want to know which biometryType is available with the user's device. So let's create the init function and call the getBiometryType function in the init. Now that we got our biometry type, let's connect our class to our views. So let's go to Content View and we'll instantiate the Authentication Manager as a state object. So at state object var Authentication Manager will be equals to Authentication Manager with parentheses at the end. In the login view, let's add the Authentication Manager as an environment object. So at environment object var Authentication Manager, two dots, will be of Authentication Manager type. Don't forget to add the environment object modifier to your preview and initialize an Authentication Manager for the preview of our login view. And also remember to go back to Content View and add the environment modifier to our login view instance here as well. So let's go to our login view. And instead of displaying a hard-coded Face ID primary button, we'll add a switch statement. And this switch statement will evaluate the Authentication Manager.biometryType. Let's take a look at the LA biometryTypes documentation. We can see that this enum contains three possible cases: none, Face ID, and Touch ID. Therefore, we'll add these three cases in our switch statement. So the first case is .Face ID. And we'll display our primary button with an image of Face ID and a text that says login with Face ID. The second case that we will take care of is the Touch ID case. So let's add case Touch ID and we'll display our primary button with an image which will be Touch ID and the text will be login with Touch ID. And finally, we have the case none. Instead of displaying the case none, we'll add a default case. In other words, if both Face ID and Touch ID are not available, we'll display a primary button with an image which will be person.fill and the text will be login with your credentials. This button will prompt the user to log in with their credentials, meaning they will log in with the username and password. Now let's test out our switch statement. We will need to run the preview 3 different times. The first time, we will build our login view with an iPhone 11 or higher. So in my case, I have an iPhone 13 and my build has succeeded, and you can see that we see our primary button with the login with Face ID button. Next, we'll need to build with an iPhone 8. This device model only has Touch ID, so you should see the Touch ID button. So you can see that we have our iPhone 8 here and we have login with Touch ID on our button. So that works. And finally, we'll need to run the preview with an iPod Touch 7th generation. As this is a very old device, it doesn't support Face ID nor Touch ID. So you should see a button with login with credentials, which is the default case of our switch statement. If all the buttons displayed are the correct ones, great. We can move on and code the function to authenticate the user with biometrics. Let's go back to our Authentication Manager and create a few new published variables at the top. The first one will be at published private set var, and it will be called is authenticated. By default, we'll set it to false. The two next variables we'll create will be for error handling, and we'll cover the error handling later on. So let's create at published private set var, which will be called error description, and it will be an optional string. The last one will be at published var show alert, which will be false. Note that we're not adding the private set for the show alert because we'll need it as a binding value later on, so the set must be accessible outside of this class. Then, right below our getBiometryType function, we'll create a new one called Authenticate with biometrics. The first line of code inside of this function will be reassigning the context variable. So context will be equals to LA context. In other words, we will recreate the context every time the user tries to log in again. If you don't reassign the context with a new one every time, the biometry won't be checked at the next login, meaning that the user will be able to access the contents of the app straight away, and usually that's not good practice. Right below this, we will add an if statement and we use the canEvaluate policy that we assigned in our getBiometryType function. If canEvaluate policy is true, we will call the evaluate policy function, which will run the biometrics and verify that the user is actually the device's owner face or fingerprint. However, before calling the evaluate policy function, let's create a letReason variable that will let the user know why we need to use FaceID or TouchID. In our case, it's to log into your account. Next, we'll call the evaluate policy function on our context variable. This function can be called either with synchronous code or it can also be called with asynchronous code. So let's do it asynchronously. We'll first need to add the async keyword to our Authenticate with biometrics function. Next, we'll call our context.evaluatePolicy, and we need to provide a policy as well as a localized reason. The policy will be device owner authentication with biometrics, which is the same one that we use for our canEvaluatePolicy function. The localized reason is a string, so let's simply pass the reason variable that we just created. Since we are calling this function asynchronously, we need to add try_await before calling this function. And since we added a try, that means that this function might throw an error. So let's wrap it in a do_catch statement, so that the catch statement will catch any error that might be thrown. We'll take care of the catch statement later on. So the evaluate policy function returns us a variable, and this variable is a Boolean value that lets us know if the biometrics authentication was successful or not. So let's save that in a success variable. And right below this line, we will create an if statement. So if success, we will dispatch queue.main.async, and we will call our self.isAuthenticated and set it to true. We need to wrap this in a dispatch queue.main.async because we cannot publish changes on the background thread and we must do it on the main thread. And since our isAuthenticated variable is published, we must wrap it in a dispatch queue.main.async. In the catch statement, we will print the localized description of the error to the console. So let's print error.localized description. And then we'll again call the dispatch queue.main.async and we'll set the error description and the show alert. So self.error_description equals to error.localized description, then self.show_alert will be equals to true because we want to show an alert whenever we run into an error. And finally, we will also call the self.biometryType and set it back to none so that the user can log in with their credentials and not stay logged out of their account. We'll take care of the login with credentials soon. So since we want to show an alert when the show alert variable is true, we should code that. Let's go to our content view, and on the VStack, we'll add the alert modifier, and we'll select the one with the isPresented. So isPresented, as you can see, accepts a binding Boolean value. So let's add a $, which means that we're binding this variable, and we'll call our AuthenticationManager.showAlert. For the contents of this alert, let's create an alert. So we'll call alert, and we need to pass 3 variables. The title is required, so let's create a text that says error. The message is an optional text, but let's still add it. And we will call our AuthenticationManager.error description. And you might see that we have an error here because our error description is optional. So let's add a fallback, and inside of the string, we will write error trying to log in with credentials. Please try again. For the dismiss button, we will add the default button, and the label of the button will be a text that will say OK. However, note that it's possible to go even further by handling each error code that the evaluate policy function might throw. You can take a look at the LA error code and create a custom error description for each error code that the function might throw. As we want to keep this tutorial short and sweet, we won't go that far and only show an alert when we run into an error. Now we'll need to connect our Authenticate with biometrics function to the UI. So let's go to our LoginView, and we will add an on-tap gesture for the FaceID button as well as the TouchID button. So let me simply change my target to iPhone 13 instead. So let's add the on-tap gesture modifier to our Face ID button. So when the user taps on this button, we want to call our Authentication Manager .authenticate with biometrics. However, if you remember, we coded this function asynchronously. So right now we have an error that says that we have an async call in a function that does not support concurrency. In other words, the on-tap gesture modifier only accepts synchronous code, and we are trying to add an asynchronous code here. So if we add the await keyword in front of this function, we will still run into another error that says that we cannot pass function of type async to parameter expecting synchronous function type. To fix this, we simply need to wrap our function in a task.init closure. So let's move this function inside of it. And you can see that we don't have any error anymore. So let's simply copy this on-tap gesture and paste it on the Touch ID button. You might be wondering why we don't add the on-tap gesture to the Login with Credentials button. As this is the fallback for when biometrics authentication isn't available, it doesn't make sense to call the Authenticate with biometrics function on-tap gesture of it. We'll need to create another function for credentials login. We'll take care of that later on. But first, let's test out our Authenticate with biometrics function. Let's go back to our Authentication Manager, and inside of the Authenticate with biometrics function, we will print the value of is authenticated after setting it. So we'll print a string that says is authenticated and we'll print its value. Remember that since we're inside of a closure, we need to add the self right before calling the variable. Now, build your application in a separate simulator and not in Xcode's preview, and we'll need to test out the Face ID or Touch ID. If you build on iPod Touch or a device that doesn't support biometrics authentication, change it to one that does allow it. The simulator comes with a built-in feature where you can run Face ID or Touch ID with a matching or a non-matching Face or Touch ID. To enable Face ID in the simulator, click on Features, Face ID, and on Enrolled. Make sure you see the check next to Enrolled. In the same menu, you can see that we have a matching face or a non-matching face. In the simulator, click on the Login with Face ID button, and if you don't see anything happening, stop and build your application again. If it's the first time that you build your app, you should see an alert that asks you to allow the app to use Face ID. So click on OK, and you should see the Face ID pop up. So let's click on Features, Face ID, and Matching Face. And now the Face ID pop-up disappears, but if we go back to Xcode, we can see in the console that is authenticated is true. Now let's try to log in again, but with a non-matching face. So let's click on Login with Face ID, and let's go to Features, Face ID, non-matching face, and the face has not been recognized. Let's click on Cancel, and you can see the alert that we coded before, saying that we have an error, and the error is that the authentication has been canceled. So let's click on OK, and you can see that we fall back to a login with our credentials. So let's take care of the login with credentials process. In a full-fledged app, you typically connect your application to an external authentication system, like signing in with Apple, signing in with Google, or any other authentication system. However, as we want to keep this tutorial short, we'll create a dummy function to authenticate a single user. You can learn how to implement a Firebase authentication service in the SwiftUI application in the Firebase Auth section of the SwiftUI Advanced Handbook. You can find this link in the text content of this section. In Authentication Manager, we will add a new function right below the Authenticate with biometrics. And this function will be called Authenticate with Credentials, and it will accept two arguments. The first one will be a username, which will be a string, and the second one will be a password, which will also be a string. The only credentials accepted in this application are Stephanie for the username and 123456 for the password. So let's check that if the username dot lowercase is equals to Stephanie and the password is equals to 123456, then we'll authenticate the user. So is authenticated will be true. Else, we will set the error description, which will be wrong credentials, and show alert will be true. Remember that this is only a dummy function and you wouldn't want to hardcode the credentials in your codebase in an actual application. Now let's create another view under the views folder. Let's create a new file and it will be a SwiftUI view. This view will be called Credentials Login View. Then let's click on Create. Inside of this file, we will need a form when FaceID and TouchID are not available. So at the top, let's add an environment object called AuthenticationManager, and it will be of AuthenticationManager type. Remember to add the environment object and create a new instance of the AuthenticationManager for the preview. Next, we'll also add two states at the top. The first one will be called username, and it will be an empty string. The second state will be called password, and it will also be an empty string. For the contents of this view, let's remove the text hello world and add a VStack with some spacing of 40 pixels. Inside of this VStack, we will add our title. Then we'll add a text field, and the text field will be a username with the text, which will be $username. And this is the binding value that we pass to this variable so that we can save what the user inputs in our username state. So right now you can see that since our title is white and our text field is also white, it's hard to see what's on the preview. So let's just add a frame with a max width of infinity and a max height of infinity. And let's also add some background color. So let's go to our login view, copy the background color that we added to our VStack, and then paste it in our credentials login view. So right now you can see our authenticator and our text field has a transparent background. We'll add a modifier called text field style, and it will be a rounded border field. And we'll also add some padding all around it so that it doesn't hug the sides of our screen. Next, we'll create a secure field, and this will be used for our password, meaning that what the user inputs in this field will be hidden. The text will be a binding value, and it will be our password state. Right below our secure field, let's add our primary button, and the show image will be false. The text will be login. On tap gesture of the primary button, we want to call our Authenticate with Credentials function that we created in our Authentication Manager. So let's add the on tap gesture, and we'll call our Authentication Manager dot Authenticate with Credentials. The username will be the username state that we created in this view, and the password, you might have guessed it, is the password that we created in this view as well. Now let's go back to our login view. On tap gesture of our Login with Credentials button, we want to lead the user to the new Credentials login view. So we'll use the navigation link. Since the navigation link only works when our app is wrapped in a navigation view, let's go to Content View and we'll wrap our entire VStack in a navigation view. So what we can do is click on Command on the keyboard and then click on our VStack, and we can embed this in either HStack, VStack, or ZStack, it doesn't matter. And we'll change this HStack to a navigation view. Now let's go back to our login view, and we will need to wrap our primary button for the default case in a navigation link. So navigation link, and the navigation link has two closures. The first closure is the action, and the second one is the label. So let's move our primary button inside of the label closure. The destination of this navigation link will be our credentials login view. Remember to add the environment object modifier to not run into a crash later on. Now let's change our simulator to an iPod Touch and build our application in the simulator. And we'll need to test out the code for login with credentials. But first you can see that the text on our button is blue when it should be black. And when we click on that, usually with the navigation link, we can see a back button here. However, since the default accent color is blue and our background is also blue, we cannot see the back button. So let's fix that first. In Xcode 13, to change the accent color, we will need to click on our assets folder and then click on accent color. Then let's click on Universal and let's open the right panel. Under color, we will be able to change our accent color. So let's change it to label color, which is black, and let's build our application again. And now you can see that the text on our button is black, and if we click on that, the back button is also black. We can now authenticate the user with the username and the password that we hard-coded in our application. So let's add Stephanie and 1, 2, 3, 4, 5, 6 for the password. And if we click on login, nothing happens. So now it's time to take care of the screen we want to show the user when they're logged in to simulate a login and logout flow. We want to keep the logged in screen simple, so let's go back to our content view and we'll need to add an if statement inside of the vstack. So let's add an if and we'll check if the AuthenticationManager.isAuthenticated value is true. If it's true, we will want to show a signed in view. Else we will show our login view. So let's move the login view inside of the else statement. If the user is authenticated, we will add a vstack with some spacing of 40 pixels. Inside of this vstack, we will add a title as well as a text that will say welcome in. You are now authenticated. Let's change the foreground color of this text to white. And let's build our application in the simulator. So let's click on Login with FaceID, and in the menu at the top, I will select a matching face. And now you can see that I have my screen. However, my screen is all white, so we don't see anything. To fix that, let's go to our login view and copy the background as well as the frame, and go back to content view and add these two modifiers to the vstack inside of our if statement. Now let's build and run our application another time. And let's click on Login with FaceID, and I will select a matching face. And you can see that we're now logged into our application. However, now that we're able to log in, there is no way to log back out and go back to our login view. So let's create that function. Let's go to our AuthenticationManager file and we'll create a logout function. So right below the Authenticate with Credentials function, let's create another one called Logout. And this function will be really simple. We'll simply set the is authenticated back to false. Now let's go to content view, and right below the subtitle, we will add a primary button with the show image value, which will be false, and a text that says logout. And on tap gesture of this button, we will call our AuthenticationManager.logout. Now build your application on your phone or on the simulator one last time, and we'll test out the complete flow of our application. So let's click on Login with FaceID, and I will select a matching face, and you can see that we're now logged in and authenticated. If we click on Logout, it will log us out of our application. So great! You finished coding the login and logout process using biometrics authentication. In this tutorial, we'll learn how to build an authentication process with FaceID or TouchID. And we added a fallback to log in with credentials if both biometrics authentication types aren't available or the Face or the Touch ID has failed. We also coded a simple login and logout flow. Of course, there's a lot more we can do to make this app even better, like implementing an actual authentication service with either signing with Apple or signing with Google or even Firebase Auth. Now go ahead and build amazing authentication flows with biometrics in your SwiftUI applications.